Hello, everyone. So today we're going to be talking about that ever important topic, labeling. So as most of you know, proper labeling in a chemistry lab is a really important issue, but it's really easy to forget in the hustle and the bustle of working in a lab. But in order to try and illustrate the importance of proper labeling protocols, I want to start with an incident that happened at UC Berkeley. So there was a group of students working in a lab process preparing copper plates for surface chemistry work. And one of the researchers was cleaning off their slides with 2-propanol. So good old friend isopropanol, put it into the properly labeled container for the 2-propanol waste. And well, that's when things went a little bit wrong because it turns out that somebody had used that bottle to store the nitric acid from the etching for the copper. And it turns out when isopropyl interacts with the nitric acid, well, that ends up generating a fairly exothermic reaction, which ended up spraying a nice mixture of nitric acid and isopropanol all over the room. So this did cause the student who was using the isopropanol to have some acid burns. Now, quick use uh, of a chemical shower managed to help keep the damage to a minimum. But the real question is, why did this happen in the first place? And the answer is improper labeling. So one of the things I do want to emphasize is that whenever you're using a solution, whenever you're using chemicals, make sure that all of your solutions end up in the properly labeled bottle to avoid issues like this. But one of the other things that's important to remember is that if you're putting any sort of solution, and yes, this does include water in any sort of beaker or container, it should be labeled properly. Even if you're only keeping extra water for rinsing off glassware in a beaker, you still need to label that beaker water, because what if it isn't? What if it's something else? And there has been numerous cases where somebody has thought bought a beaker of clear colorless liquid was water and something disastrous happens. I encourage you to talk with some of your professors. They'll probably have at least one incident from the clear colorless liquid camp. So again, one of the things I want to emphasize is always label all of your solutions, even if you think it isn't a big deal, because turns out occasionally it will be. And I've seen more than my fair share of chemical mix-ups in, again, the rush of working around a chem lab. So when you're labeling a container for use, no matter how short, all your chemicals have to be labeled with at least the name of the chemical. So whatever is going to be present. But especially when you're storing chemicals for prolonged usage, so more than say 30 minutes, you should prepare a full chemical label. And that should include the name of the chemical being used. Again, no abbreviations, no KHPs, use the full name to avoid any sort of confusion. And especially if the solution the chemical is in solution, make sure you list the concentration, because I'm going to treat a 6 molar HCl solution very different from a 0.01 molar HCl solution. So again, this concentration can be a very important issue. And then again, any related hazards. And don't forget your name, because you're the person who prepped the solution. So if something goes wrong, we know who to talk to. And again, when you prepared it. And this is especially important as a lot of solutions tend to change in nature based on how long they've been stored. And so knowing how long a container has been sitting in place is a really important issue. And then make sure that you reference the notebook page where you prep the solution. That way, in case there's any sort of special information about the preparation or notes of something that may have happened along the way, or any sort of minority species that might be present, there's a full resource available to help figure that out. So a good example of what a label should look like can come from the general idea of labels provided by some companies, where it has a section for the chemical name, which is typically not just for the name of the chemical, but part of that is going to be the concentration. So, for example, zero point 0.1 molar hydrochloric acid. And then for the manufacturing name, congratulations, you're the person produced it, and you need to have all the details, such as when it was prepared and where to go for additional information. And then again, any special hazardous information goes in the diamond. If you're preparing, your own slides, make sure that you have enough room to provide at least this bare minimum of information. And yes, this means that your labels may be a lot bigger than you'd prefer them to be, but it will keep everybody safe in the long run. However, one of the things I do want to emphasize is that it turns out that a label's only going to be useful if you can read it. And as most of you have seen, any chemical who sits in a lab long enough might start suffering label degradation. And one of the leading causes for the breakdown of a label is if I pour solution over that. So let's say I have a typical container, typical bottle of chemicals. It may have, say, a handle. If you're going to go ahead and put the label on, try and put it below the handle and away from any area over which solution may be poured. And again, trying to make sure that even if there isn't a handle, that when you do pour solution, you try and pour it over the side that doesn't contain the label to help keep label integrity present. So this is, again, a good general guideline. But even with that said, it isn't uncommon for labels to essentially slowly corrode. If your label is starting to lose integrity, it's encouraged that you go ahead and remove the label and then try and clean the surface so that you can put a clean label down on the surface. If the label is stuck to the surface, just try and paste your label over top while trying to make sure that it's secured as well as possible to prevent them both labels peeling off simultaneously. Now, one of the other things that's worth noting with the use of labels is there's a couple of methods that are frequently used to try and help identify what might be present in a bottle. And one of those is provided by Fisher Chemical, which is called a ChemAlert System. So these are essentially color-coded bars that provide instant information as to what sort of hazards might be present with the material inside. So let's say I've got acetonitrile. Its primary hazard is going to be fire hazard, and you can see that with the NFPA diamond. But it also provides that information with a colored stripe at the bottom of the label and a colored ring below the cap. Now, so for example, acetonitrile's primary hazard is a fire hazard. So it has a red bar and a red ring. If it was primarily a health hazard, that would go to blue. Reactivity or oxidizing hazards go to yellow, and then white for corrosive. And if it's just a general hazard, that would go to gray. Now, one of the things that I want to make sure that you realize is that this is only a general guide, because it turns out that if I have something that's both a health and a fire hazard, we're pretty much going to give the more significant hazard place of primacy. So thus, we don't have red and blue for acetonitrile, we just have red. And so we don't have a lot of information conveyed, but we have a certain subset of the information conveyed well. One of the other things that you should watch out for is the fact that not all companies will make use of this color system. so you may not always have the ChemAlert system to fall back on. And the final thing that you should watch out for is that bottles are frequently reused, as demonstrated with the mislabeled isopropanol bottle. And so even if the label has been pasted over, you can't always trust the ring because it may have belonged to the last chemical in that bottle. So again, these are some of the things that you should watch out for with chemical labeling, which again helps bring us to a general idea of what ways we can go about trying to make a lab safe. And as we've seen, one of the biggest things that we can do is just make sure that everyone is aware of what dangers are present in any sort of materials that you're working with. But in general, the most effective thing you can do is try and eliminate any dangerous or toxic chemicals from typical practices in the lab. However, sometimes you just have to work with hazardous chemicals because they're the only ones that make the chemistry work. If that's the case, then then you can try and fall back on engineering controls. So these are things such as putting in secure blast shields and better ventilation to help reduce any risk and hazard. Now, these often are very effective, but unfortunately can be fairly expensive and don't always cover every possibility. So after that, we have essentially administrative controls and work practices. So this is the things that people can do. So this is some of the things that I'm trying to introduce you to in the course of this safety section is things that you can do to become a safer worker. And we'll talk a little bit more about these later. And then finally, we have the one that most people emphasize the most, but it's kind of the last line of defense, and that's personal protective equipment, or PPE. So this is your lab coat and safety glasses. And these do tend to be fairly effective, but they only work when something has already gone wrong. So usually we need to have a failure at these first 3 levels before PPE ends up even coming into play. And PPE doesn't prevent something bad from happening. It just makes it less dire when it happens. Now, that in and of itself can be fairly important, and so we will also be talking more about PPE as we go forward. So, hopefully this gives you an idea of where we're moving on. As next up, we're going to be talking about some engineering controls based on what we now know for labeling and chemical reactivity. Next up is chemical storage. Till then, take care.